The last two things that you need to be able to do for this section are two formulas that would probably be in your best interest to have written down on a piece of paper somewhere. Okay, the first is an arc length. Okay, arc length is designated by the lowercase or cursive, usually S. In this case, italics maybe. Okay, and then the theta value is your angle in terms of radians. Okay, and then the other measure that you have to have is the arc area. Okay, and this is called the area of a sector. Okay, and that's designated by the area. Capital A is equal to 1/2 r squared times theta. Again, where theta is in terms of radians, not degrees. And so in each of these cases, you would need to convert into radians if it was not given in terms of radians in order to solve for those. All right, so let's say I gave you the following problem. If I gave you a central angle of 50 degrees, which is your theta value, and I gave you a radius of 9, okay, so here is the arc length, okay, and then the area would be this whole shaded region. Okay, I want you to see if you can calculate the arc length and the area of that measure, please. All right, so in finding this arc length is equal to the radius times the angle measure in terms of radians. Okay, so your radius is 9. Your angle is 20, your angle is 50. But we want to convert out of degrees and into radians. So what is the conversion? So 2 pi is equivalent to 360, or 1 pi is equivalent to 180. Okay, so pi over 180 is your conversion. And so if you're looking at this, you can now perform your calculation. Okay, so if we take 9 times the quantity 50 times pi divided by 180, okay, we get our answer of 5 pi over 2. Okay, for the most part, you guys are going to be leaving your answers in terms of this rational form. So if you entered this online, remember 5 pi open close parentheses /2 would be the measurement. Since it's measured in inches, arc length is also going to be in inches. I'll usually provide you with the units in the answer. Olivia?
Wait, don't we have to put the radian into degrees too?
The radian is not degrees.
Or, I mean, okay.
In terms, we converted out of degrees by using this conversion.
Okay, but you don't have to put the radius into like...
Oh, no, the radius is just, no. Okay. And then the second calculation? Yes.
Why didn't you put anything in the parentheses?
Just, this is how we designate the symbol pi. It's just so that it can separate it from anything that might be falling after it. Okay. All right, guys. So the area calculation then, 1/2 the radius squared times the angle, the central angle measured in radians. So once again, we take 1/2. Here we have our radius, which is 9 squared. times, it's the same conversion. So 50 degrees times pi over 180. And so if we calculate this, okay, so 1/2 times 9 squared times the quantity 50 times pi over 180. Close it off. And we get 45 pi over 4, which again, in terms of how you would enter this, 45 pi open close parentheses slash 4. Okay. The units in this would be square inches if you had to write those, but again, I'll usually include those for you if you need them.